Okay, this is the cardiac output Fick method, or oxygen consumption method. So here are the variables that you need to know in order to do the Fick method. You have to know the oxygen consumption, you have to know the arterial oxygen content, and you have to know the mixed venous oxygen content. So the first thing is to figure that out. So first of all, oxygen consumption is the rate at which the lungs use oxygen. It's expressed in milliliters of oxygen per minute. And again, this is a normal that you will want to know. Your normal oxygen consumption is about 175 to 250. Now here's the problem, and I've looked into several textbooks, and so I don't really know how they're going to give it to you on the registry. But your normal just oxygen consumption is 125 milliliters of oxygen per minute times your BSA, which BSA stands for body surface area. So here's the thing. Either they will give you the oxygen consumption with the BSA already calculated in with it, or they will give you the oxygen consumption, which is always 125, and they will give you the BSA, and then you have to figure it out yourself. Okay, and I'll explain that a little bit more when we get to the other examples page, um, because I'm not really sure how they will give it to you. They will either give you the actual oxygen consumption, which would be 175 to 250, or they will give you the 125 and the BSA, and then you have to figure out the oxygen consumption, and I'm not sure how they're going to do it. Okay, um, then okay, the other variables are the arterial oxygen content and the mixed venous oxygen content. And so these are the first formulas you have to know, because here's what they do. They will give you the oxygen saturation, your arterial O2 sat and your venous O2 sat. Also, at this time, I need to point out that mixed venous, in this regard, in this instance, mixed venous blood comes from the pulmonary artery. The best place to get mixed venous blood is from the pulmonary artery. Um, so that's where this so that's where they get this. That's where they get the mixed venous blood from, is from the pulmonary artery. They draw blood from the pulmonary artery and then check its oxygen content. And again, they'll be given to you as saturations, which is like a percentage. Your normal arterial oxygen saturation is, oh, I don't know, 95 to 100%, where your normal venous oxygen saturation is about 75%. So you'll take that percentage, so let's just say it's 99%. Okay, 99% equals 0.99 in decimal form, so you're going to need to know that. Okay, the other variable that they will give you is the hemoglobin. Then you will take this 1.36 and this 10. So these are the constants. This 1.36 and this 10 will be constant for every problem that you work that involves arterial oxygen content and mixed venous oxygen content. Okay, so now I've scrolled on down to the actual formula for the Fick cardiac output formula. The Fick formula is O2 consumption divided by arterial oxygen content minus mixed venous oxygen content. Okay, so here's an example. So again, they will give you the percentage, and you have to convert that into content. So the AO is 94%, the PA, which is mixed venous, is 74%. They've given you the hemoglobin, which is 13 grams per deciliter, and they have given you the O2 consumption, which is 200. Okay, so the first step is to figure the arterial oxygen content. So again, you take your 94% and change that into a decimal, 0.94. Then you multiply that by your hemoglobin, which is 13. And then the 1.36 and your 10 are constants. They will always be part of this problem. So the answer, so if you multiply all that out, it comes to 166.192 milliliters. So that is how much oxygen is in 1 liter of blood. Okay, same thing with mixed venous. Take your 74% and convert that into a decimal. Then again, your times your hemoglobin, which will be given to you, times your 1.36 times your 10, and then it comes up with 130.832 milliliters of oxygen per 1 liter of blood. Okay, so then you take, so that's the first step, is finding the oxygen content. Then you can work the actual Fick formula, which is here. So you take your 200, which is your oxygen consumption, and divide it by the difference between the arterial oxygen content and venous oxygen content. And if you work that out, then it becomes 5.6 liters per minute. So the cardiac output is 5.6 liters per minute.